Hello everyone, this experiment is regarding static NAT. Static NAT is nothing but network address translation configuration statically. What we exactly do here is we need to configure the NAT in all the routers. So here we'll configure the NAT in the router 1, and we need to assign the IP addresses to all the PCs, as we have assigned the IP addresses to all the PCs here, and then we need to assign the IP address to the router in all the similar fashion, and NoShed will make the link up, and we have assigned the IP address to the server as well. So for static NAT, we need to configure the router 1 initially. We'll give all the IP addresses and all the subnet mask and everything, whatever is required for a basic router configuration. Then after configuring all the IP addresses, what we exactly need to do here is we'll go to the after giving the IP addresses, we can see here we need to give the IP route 30.0.0.0 to 55.0.0.0 and then 20.0.0.1. What it actually tells us is the route from this network will go through this network. That is, network address translation, as we all know, it is basically converting the private IP to the public IP and then transferring the public IP to the private IP when the packet is coming into the LAN network. So a packet from this network, that is, suppose this network is 30.0.0.2, will go out of this router. Will go out of this router. Say suppose I have given it as 50.0.0.1, as I'll configure it. So it will go out of this router as some public IP, and then when it will return from this router, it will come again as the 30.0.0.1 or 2. Okay, so here initially for the router 1, we need to assign the IP addresses to all the router interfaces, and then we can see what we are supposed to do here is we are supposed to assign the IP route 30.0.0.0 and then the subnet mask and then the exit interface. That is, here what 30.0.0.0 is this network. So basically a packet going from this network with a subnet mask of 255.0.0.0 because it's given here as /a will come to this router from this serial interface. That is, see, just 220.0.0.1 is the interface IP address of serial 2/0. So to this interface, I'll basically give IP route 30.0.0.0, then 255.0.0.0, and then 20.0.0.0. That's 0.0.0.1. Okay, so here I'll give 20.0.0.0.1. Then I'll press enter. I've already configured all the configuration. After this, I need to press enter. After pressing enter, what I need to do here is I need to give IP NAT inside source static 10.0.0.2 to 50.0.0.1. So what it basically means is any packet coming from this network should get translated to this network. That is, any packet that is coming from inside source as 10.0.0.2. We can check here the 10.0.0.2 network is this network, that is fast Ethernet 0/1. So any packet that is going to this network will become an IP address, will have an IP address of 50.0.0.1. And then we need to configure the IP address and the interface fast Ethernet 0/0, and then we need to tell IP NAT inside. That is, in this interface we need to tell that IP NAT inside whenever it gets inside, and then the packet should again get translated to the respective IP addresses. So similar manner we need to configure the router 0. For the router 0, all we need to do is we need to configure the IP address in the similar fashion, and then we need to provide IP route 50.0.0.0 to 55.0.0.0 to 20.0.0.2. So what it means is, it means that any packet that is coming from this network to this router will get converted into through this interface, that is serial 2/0 interface, which has 20.0.0.2 will get converted, and then here the NAT translation occurs. That is, private IP gets into a public IP, then the public IP gets into a private IP again. So for router 0, IP route, it will be IP route IP root 50.0.0.1 and then 255.0.0.0. So 250.0.0.1 and then 255.0.0.0 and sorry, 250.0.0.0 to 20.0.0.2. Here we can see it's 50.0.0.1 because the IP addresses can get translated 50.0.0.1, 2, 3 for anything, right? And then it is 20.0.0.2. So this tells that any packet that is coming from this network, that is from 50.0.0.2 0.0, as soon as it reaches the router 0, it will get translated and will be given to the respective PC according to the IP addresses assigned. So here we can check the IPNet translation as we need to ping from the source 50 dot ping from any of the PC. When you try to ping from any of the PC to 50.0.0.1, I will try to ping from any of the PC. Command prompt ping 50.0.0.1. So it will show pinging 50.0.0.1 with 32 bytes, and this pinging should be successful. So this is successful. This shows a request timed off just because of a time lapse. So it shows successful. And again, when I try to ping to the network 10.0.0.2, suppose my network is 10.0.0.2, which is the actual IP address of the server, it will show destination host unreachable. That is, this 30 network never knows what is the IP address of the server. Only it knows the IP address of the server is something related to 50.0.0.0, but it does not know that the actual IP address of the server is 10.0.0.2. Here the IP address translation occurs, which is called as network address translation, and it is very useful in a large administration where a packet from a network goes out of the network. It is recognized as that organization's net packet. So this is basically used for security purposes. Thank you.